in your Unit 4 notes packet. And again, we are only going through part 4 for the Unit 2. We edited it, so only up to part 4 for the notes for Unit 2 will be on the Unit 2 test. What is in your packet that I gave you as part 5 and part 6 is getting pushed to other units because we just don't have time to cover it all before the end of the 9 weeks. We need to get our tests in. Okay, so only part, we're doing part 3 today, and then we'll only have part 4 left, and we'll be done with Unit 4. Your test is going to be Tuesday, which is October 5th. All right, so what you need to remember from last week, from parts 1 and 2, are what the different parts of the equation mean for the graph. Okay, because the whole point of this section is to write the equations from the graph. Okay, last week we were given the equations and we made the graph. Now we're going to look at what if we're given the graph or the attributes of the graph and we need to write the equation. So we need to remember what all of these pieces mean. Okay, so what does the A value help you determine? The amplitude, what is the amplitude? It's the half the height of the graph, right? It's the absolute value of the A. Y'all remember that? Okay. All right, sorry, I had to finish writing that. Okay, so the amplitude is the absolute value of A, and when you're looking at the graph, that's the half the height. Okay, so from the midline up to the maximum, or from the midline down to the minimum, the distance is the amplitude. Okay, now how do you get that midline that you measure the amplitude from? What part of the equation is the midline? What if you don't have the graph? You have the equation. Somebody said it over there. D. Okay. The number added or subtracted on the outside, that's the vertical shift. Okay, so the midline is y equals that number. Okay, we draw a dashed line at y equals d, that's the midline. Okay, the midline is showing you where the vertical shift is. Okay, now I've got it written in 2 forms here. I've got it written with the plus d at the end of the equation. You can also have d at the beginning of the equation. Okay, both are correct. I tend to use this second option because when let's say there's not a horizontal shift and so there's no parentheses, and then you have like plus 3. Some people tend to get mixed up and think the plus 3 is with the x inside, even though there's not parentheses. That's a very common mistake. So to prevent that, when I'm writing equations, I put the d at the beginning. Okay, so there's no interpreting that as part of what you're taking sine or cosine of. Okay, so you can write the d at the end or you can put the d at the beginning. Okay, all right, and then let's see, the phase shift or horizontal shift, the way that I have written it with the b factored out of the parentheses, you're left with x minus the horizontal shift in parentheses. Okay, so, but remember, it could be written with the b inside parentheses, and it looks like this, okay, where the b is distributed into it, and then you no longer see the horizontal shift, you see the c value. Okay, but remember, it needs to be the opposite of the number that you see there. That's why I put the minus the horizontal shift, because it's negative c divided by the absolute value of b. okay? So it's different if the b is factored out, which is how if I'm writing an equation, I'm going to write it with the b factored out. Okay, but sometimes if the equation's already written, you'll see it with the b factored in. All right, and then the last piece in the equation is b, and b is how we determine the period. Okay, remember the period is 2 pi divided by b. Or what would it be if we were in degrees instead of radians? Yeah, 360 divided by b. Now, that's when you're given the equation, you know the b value because you can see it in the equation, you can plug it in and find the period. But if you're given the graph and you're trying to write the equation, you have to figure out what b is. You don't know b looking at the graph. Looking at the graph, you can determine the period. So you have to work backward. So remember, if you work this backward and solve for b, b is 2 pi divided by the period as well. Okay, so it works in reverse as well. If I solve for b, I multiply the b over and then divide the period over. So the b and the period can switch spots depending on which one is given. Okay, or of course, 360 divided by the period if you're in degrees. Now, one thing we need to make sure we understand is that positive or negative in front of the a. Okay, when you're writing your equation, you're like, how do I know if my a is supposed to be positive or negative? Or if I'm writing my d in front, how do I know if I put plus or minus before the a? Okay, the plus or minus for the a will depend on which trig cycle you use. When I say which trig cycle you use, I mean, are you using sine or cosine, and are you using positive sine or negative sine, or positive cosine or negative cosine? Okay, so those graphs in your notes right here show those 4 different cycles. Okay, so here are the 2 original parent functions, one cycle, sine and cosine. Okay, you should recall that sine starts at the midline and goes up first. Goes up, then back through the midline to the low, then back to the midline, and then it repeats itself. Okay, so sine starts at the midline and goes up. Negative sine, you can see it's a reflection across the x-axis. Okay, what was the maximum is now the minimum. What was the minimum is now the maximum. Okay, it's switched. Okay, so negative sine still starts at the midline, okay, the halfway point, and goes down first. Okay, so do you get the difference in sine versus negative sine? So in that equation, if the graph that I'm looking at starts at the midline and goes up, I would use a plus here, a positive. But if it starts at the midline and goes down, that's when I would put a negative in front of the a. Does that make sense? Okay, now what about cosine? Cosine starts at a high point and ends at a high point. So a cycle of cosine is high to high. So if the cycle you are looking at in your graph goes from high point to high point, that's a positive cosine cycle. So it would be a plus in front of the A. The A would be positive. Okay, but if it's the reciprocal, it goes from low point, not the reciprocal, excuse me, the opposite, negative cosine, it goes from low to low. In your equation, your A would be negative. So if either of these are the cycles you're using, the A value is going to be negative. So follow that? Does that make sense? Okay. So let's look at an example. We've got two graphs side by side. They're identical, aren't they? Does everybody see that these are the exact same graph? We want to write the equation as a sine function, and we want to write it as a negative sine function so that we can see the difference. Okay, so we're going to write one equation to represent this graph as a sine function, and then the same graph, we're going to write it as a negative sine function. So before we can get started, we need to scale our axes. It says to scale the y-axis by 1s, 2, that goes all the way up to 5, and it comes down to -1. Okay, and the that was the y-axis. The x-axis by 45 degrees. So this one's in degrees, so every tick mark is 45. Okay, so that means this is 90, this is 180, 270, and 360. All right, so when you have a graph and you want to write the equation, the first thing I would do is figure out the height, okay? From high point to low point, maximum to minimum. How tall is the graph? 6, because it's going from -1 to 5. That's 6 units. Why do you think I would find the height first? What will that help me establish? The what? The amplitude. What would the amplitude be? The amplitude is half the height because it goes from the midline to the high or low. Okay, so if all the way from high to low is 6, the amplitude is half of that. So from your low, you can go up 3 because it's half of 6, or from your high, you could come down 3. Whichever way you prefer to think of it, either way, it's an amplitude of 3. So both graphs have the same amplitude. And that tells me where I should be drawing my midline. Okay, so if I'm at -1 and I go up 3, where am I? At 2. Y equals 2 is the midline. Okay, same thing over here. If I'm at 5 and I go down 3, it's still at 2, right? Okay, so they have the same midline, same amplitude. Okay, so I'm going to label that my vertical shift is up 2 because that's where the midline is. All right, now, where would a sine cycle begin here now that I see the midline? Sine, we said, starts at the midline and goes up first. Okay, right here at 45 degrees, we're on the midline and it's going up from there. So that is my starting point. When I say my starting point of the given cycle that I'm trying to write, that tells me my horizontal shift is to the right 45 degrees. Does that make sense? I didn't start on the y-axis. I started at 45 degrees. The horizontal shift is 45 degrees. I'm going to go ahead and highlight that sine cycle. Okay, midline to high to midline to low to midline. That's a sine cycle. Okay, so what about the negative sine cycle? That should start at a midline and go down. Okay, so where would be a starting point on here for negative sine? Not 210. These are 45 degrees. So what's 180 plus 45? 225. There we go. So this one has a horizontal shift to the right, 225. I'm going to highlight a different color here. Negative sine would start here. Now, I don't even see the full negative sine cycle, do I? But I know it keeps going, right? So I know it's going to continue and be a full cycle, but I actually only see half of it. But that's okay. You don't have to see the entire cycle. You just have to know where it would start, because that's your horizontal shift. Does that make sense? Y'all get your heads up. Jordan, Ethan. You nudge him, Thomas. Behind you. Yeah. On the purple, in the purple? Yeah, my pen like makes random stray marks for some reason. That is a V. Vertical shift up to there. All right, so again, I don't need to see the entire cycle as long as I know where the cycle starts. Okay, now the last thing I need, I've got horizontal shift, vertical shift, amplitude. I need the period. Okay, so the period is like the width of your cycle. Okay, left to right, from beginning to end of the cycle, how wide is it? So this started at 45 degrees, and this would be at 405. So 405 minus 45, that's a distance of 360 degrees. So the period is 360. What will that help me find for my equation? The B value. The B is 360 divided by the period. Well, the period is also 360. So B is a 1. Okay, that means when B is 1, that means the period has not changed from the parent function. Remember, the parent function period is 360 or 2 pi. Okay, so if your period is 360 or 2 pi, that means B is 1. There's no change. So now over here, let's say you weren't looking at this. Even though negative sine is the cycle we're writing the equation for, you could measure the period on a cycle that you see the complete cycle for. Like, it doesn't matter. But if you see half a cycle, you can also use that. You can tell yourself, okay, well, half a cycle, half the period is 405 minus 225. That's 180. Well, if half the period is 180, what would the full period be? 360. So if you only see half a cycle, just double the width. Okay, or measure where you do see a full cycle. It doesn't matter where you measure. Okay, as long as you know this is the starting point. Does that make sense? Okay, so now to write our equation, I'm going to start with my D. I'm going to do plus or minus, and both of these were sine. So I'll have A and then sine of B times X minus the horizontal shift. This is the format I'm going to use to write my equations. Okay, so we've got the B came out to be 1. The amplitude we said was 3. And the vertical shift we said is 2. And then the horizontal shift is going to be different depending on if it's positive or negative. Okay, so we're going to have 2 different equations here, one under each graph. Okay, so for the graph on the left, okay, The vertical shift was up 2, so that's a positive 2. And I'm writing it as a positive sine cycle, so I put a plus here in front of the amplitude of 3. We said the B value came out to be 1. Do I have to write 1 or can it be understood? Yeah, I don't need to write 1. I'll know if there's no number here, it's an understood 1. Okay, that horizontal shift was to the right 45. So in the function, in the equation, it's minus 45, because remember, it's the opposite for the inside. Now for this one over here, okay, the vertical shift did not change, but I'm doing a negative sine cycle. So this needs to be a minus in front of the A value. B is an understood 1. And then the horizontal shift is 225. So minus 225 degrees. So you can see only difference when you change the cycle to negative sine from positive sine is the horizontal shift. Every other piece, the A stayed the same, the A is the 3, the D stayed the same, the B stayed the same. Okay, the only change is that horizontal shift. Okay, so you may want to make a little note of that. Everything is the same except for the horizontal shift. Okay, that's the only thing that changed when you changed your plus to a minus. That's the only attribute affected. So both of those would be correct answers. If I asked you to write the equation of that graph, and I didn't tell you what cycle to use, you could have used positive sine or negative sine. You also could have used cosine or negative cosine. So there's actually 4 different equations that would be correct. Does that make sense? All right, one more example. We're going to do cosine and positive and negative cosine for this graph. And this one's going to be in radians. Okay, so I'm going to scale the axes first. And it does say to scale y by 1 again. And it says to scale the x-axis by pi fourths. So 1, 2, 3, 4, there's pi. There's 2 pi. So I go from 0 to -4. So the height is 4, right? What's the amplitude? So from the low, go up to, or from a high, come down to. It doesn't matter. That's going to get you to the same spot at -2 for the midline. So we now have our amplitude is 2. And our vertical shift is down 2. So that means it's negative, right? Okay, so the D is going to be -2. All right, now starting points. Cosine, positive cosine, what did we say? Would go from what to what? Peak to peak, high to high. Okay, maximum to maximum, however you want to think of that. So I could have this as my starting point and look at this cycle. Is that the only cycle for positive cosine, the only starting point that I see? I could have chosen this as a starting point, couldn't I? And looked at this one. Now I don't see the complete cosine cycle if this is my starting point, but that's okay. I could write it for there. So there's actually infinitely many correct answers because the graph goes on forever. So you could choose any maximum to be your starting point. Now, for the sake of doing this work in class and like trying to have the same answers, we're just always going to pick the one closest to the x-axis, okay? Unless it's specified which one you're supposed to use. So I'm just going to use this first peak as the beginning of my cosine cycle. So I'm going to look at this highlighted one. Okay, what about if I'm doing negative cosine? I start at a low point. Okay, so this could be my starting point, or this could have, but I'm just going to choose the first one I see. Okay, so cosine was there. Now negative would be low to low here. So let's measure the period. Okay, so if these are pi fourths, that's 1, 2, 3, 4 pi fourths is the distance, which is just pi, right? So my period is pi, which means b is 2 pi divided by the period. What does that come out to be? Just 2. The pi's cancel. So b is 2. Okay, it should be the same for this one. Let's verify we did it correctly. So it's 1, 2, 3, 4. And those are each pi fourths. So 4 pi fourths is indeed pi for the period. So we got the same period, same amplitude, same vertical shift. The only difference is the horizontal shift, the starting point. So this one is at pi fourths, because it said to scale by pi fourths. So that first grid line, or that first tick mark, is pi fourths. Okay. Here it's the third tick mark, so that's 3 pi fourths. Okay. So when I go to write my equation, I'll write them together, side by side, as we fill them in. So what is D? The vertical shift. -2, because it was down, so we need to make sure it's -2. Okay, now this one, we're doing a positive cosine cycle. And what's the amplitude? So +2 cosine. Here we're doing a negative, so it's -2 cosine. Okay, and then what's the b value? 2. Oops. And then the horizontal shift for this one is pi fourths, so it's minus pi fourths in parentheses with the x. And over here, it's 3 pi fourths. There are a lot of 2's there, so we're going to highlight and make sure you knew where the different 2's came from. So first of all, this was negative cosine, and this was positive cosine. So the b value is the same right there. The vertical shift is the same. And the amplitude is the same. The only thing that's different is the horizontal shift. But both of those are correct for the equation of this graph. Y'all follow? Now, one question I did get last period, so I want to address it in case somebody in here has the same question. On the assignment y'all were doing Friday, that activity, the b is not always factored out. Now, if you were simply asked to write the equation, this is it. You're good. But if it was like a multiple choice question and none of them had the b factored out, you would need to go ahead and distribute the b to write it with the b in the parentheses, right? So this would look like 2x minus, and then what's 2 times a quarter is a half, so pi halves. So if the b was factored in, or I should say multiplied in, distributed in, not factored out, this is what the equation would look like. That's correct also. Do y'all understand the difference of the b being factored out versus distributed in? Okay, so just be careful with that. I will tell you, when I'm writing problems, I'm always going to write them with the b factored out, because that way I can see the horizontal shift. Pi halves is not the horizontal shift. Okay, so just be careful with that. I do know on the assignment, the activity that y'all were going around the room on Friday for those 8 problems, some of them had a lot of them had the b in the parentheses. So you just be aware of that. If you did not finish that assignment, I think these notes may help answer some of the questions you were having. I know there was at least one that was a graph given and you had to write the equation. And then I think there was a few where you were given the attributes, like you didn't have a picture, but you were told, hey, the period is pi, the horizontal shift or the phase shift is pi fourths, the amplitude is 2, and the vertical shift is down 2, write the equation. If you have all of that just listed, you can still write the equation. You don't have to see the graph if you're given the attributes. Does that make sense? Okay, so if that doesn't answer all of your questions, do as much as you can tonight. But if you still have questions tomorrow, we will go over some and you'll have some class time to work on finishing that up, and it will be due on Wednesday. So the activity from Friday is due at the beginning of class Wednesday, and you should have a little bit of class time tomorrow to work on it and ask questions about it if you're still unsure. And then the Delta math from last week is due before midnight tonight. Okay, so make sure you get that Delta math done before midnight.